Welcome. This is part 2 of the most important class for moment of inertia. I first thought of uploading all the parts in single class. Then I decided not to go for it because it will become too lengthy and editing problem is there. And also people want part by part. I told with all concepts, also procedure. And remember, little later when we start calculating moment of inertia, this class in 4 or 5 parts, I think 4 parts most probably. First you have to go through thoroughly through each and everything, master it, then only start the questions. So part 2 is application of parallel axis theorem. You already know what is parallel axis theorem. A statement all given earlier. I won't repeat. You go back to the old class where I told parallel axis theorem considered. I derived the equation I about any axis equal to ig plus ah square with all words I given there. You go through it first, but there it is only mathematical part told. But today I am giving you application class. Actually, application of parallel axis theorem is most important. M.I. most important for moment of inertia. M.I. square. Okay. Most important for moment of inertia calculation. So systematically I will tell you all the concept involved. I will see that once you understand, go through this class and thoroughly understand, in future you will have no difficulty to apply parallel axis theorem. Okay, now I will remove all this one and make ready for application. Start now. You can make a small heading here. Calculation of moment of inertia. Some heading you write here. Red color will do. Calculation of moment of inertia using parallel axis theorem. You do one thing. You write big as possible. Write as big as possible because I forgot to write it. Already I told last time. You write it as big as possible. Now, what all I tell, listen carefully, go through repeatedly 10-15 times till you master it. See, this is area is A, or see green color, area considered for finding moment of inertia about any axis. Say here in the class about AB and CD. Make a note here. AB and CD are any axis. They are any axis. Later, they can be centroidal axis for the entire lamina. This is not the entire lamina. This is only considered area. I will explain more clearly further later. So, this is the area, randomly see some area. Area equal to A. Okay, I don't think green color. Area equal to A. This actually should be all green color. Area considered for finding moment of inertia about any axis, red color. Moment of inertia of the green area about red axis. Okay. Now, very important, G. See, usually centroid, we write capital G. No, because it is possible that this area considered is not the entire cross section or entire area. For the entire area, centroid will be somewhere else, capital G. Whenever I consider component, see, this can be a part of the area. You can make a note. What area we considered can be part of the area. In the second round, I am explaining it. So, I will use small g. Of course, this small g can coincide with capital G. That is something else later. G means centroid of that area considered. See, of this area considered. Or you can write here centroid of area considered, or simple language, or its own centroid. Its own centroid. I am going to explain in a very simple way. Suppose somebody may tell, he is telling very easy way, simple, no what standard English like that, no standard level, come in front of me, I will show you my standard. This all I am telling so that everybody will understand. It is not that I follow this way, I don't require all these. The moment you want a parallax theorem anywhere, I can make out easily. I don't have to worry, this is the area, not required for me, but for you required. Okay, now one axis AB, one axis CD, you write here. About AB and CD, see, any axis, later, see, later, it can be centroidal axis, XX or YY for entire lamina. And this is not entire lamina, this is only a part of it. So suppose, imagine, if this is the entire lamina, this G will become capital G. Okay, leave it now, time being sufficient. Now, you write this much first, this much you write. Then come this side. Moment of inertia about AB. About AB. Now see only AB. For that area considered. See, for that area considered of A. That is shaded area, green color shaded area. Now, this is the area considered. I cannot reproduce the same area here, this way zigzag. See, centroid G, I told. Centroid of the, I already told, see, mentioned here. G is centroid of that area considered, or its own centroid. Never bother about centroid for entire cross section or the whole area. No. This only what we want to consider, how to find moment of inertia of this area. Okay. Area considered is A. I wrote here, area considered is A, and I write here, for this area, we want to find, see, we want to find, how many times I am writing, I don't know, find moment of inertia about AB axis, using parallel axis theorem. Written so many times. Okay, this area. Now, this is centroid. What you do is, see, now AB, once again I wrote, axis about which moment of inertia is to be calculated for that area considered. See, for that, here I wrote, for this area, I am here only for this area, here for that area. When I am here, I will tell this one. When I go there, I will tell that one. Axis about which moment of inertia is to be calculated for that area considered equal to A. Okay, what you do? First, from G, here see, centroid of the area considered. From G, draw perpendicular H to AB, H suffix AB. H is the perpendicular, H suffix AB to AB. That is axis from the centroid of the area considered, draw perpendicular to what? Draw perpendicular to the axis about which we want moment of inertia of this area considered is to be calculated. Okay, then draw perpendicular. Now, immediately come this side. Then, by parallax theorem, IAB, again I wrote, shall I write once again? How many times I will write? IAB, okay, right. Okay, I write moment of inertia of that area considered, hatched area considered about AB. Okay, about AB. To make more clear, how many times I am writing about AB. So, I about AB equal to, come to centroid. Through centroid, you draw an axis that is called centroidal axis. See, green color, centroidal axis or centroidal axis parallel to AB. If AB is here, you draw a green axis, see, green color. AB, say, axis parallel to AB passing to centroid. So this is centroidal axis parallel to AB. So centroidal axis parallel to AB means parallel to AB, axis parallel to axis. See, parallel to AB means, I'll tell you, that is parallel to axis about which moment of inertia is to be calculated about this, for this area considered. Okay. Now, then I about AB equal to IG. IG means moment of inertia of the area considered about its own centroidal axis, this axis, its own axis, parallel to AB. Parallel to AB, or to make more clear, I will tell you here, this IG is, see, about this axis. This IG is about this axis. So crystal clear told. See, this IG is about this axis. It is about this axis. You can write once again, that is axis passing to centroid of the area considered and parallel to AB plus area of this area, whatever area, into perpendicular distance from the centroid of the area considered to required axis, HAB square. Some people do one thing, for HAB, I won't write here. See, you should write here. No, you write here, no space here. Red color. Okay, right here. A is not required. You write, no space here, right. Perpendicular distance from centroid of the area considered to axis about which moment of inertia is required. That square. Or, right here, some people, they call it IG plus AS square. They will tell H is the perpendicular distance between the two axes. Why two axes? There are only two axes here. One is the required axis, other is centroidal axis, between the two axes. Either you can call perpendicular distance from centroid of the area considered to the required axis, or you can tell perpendicular distance, see, you write it, or you can tell perpendicular distance between the two axes, this distance square. This will give I about AB. Okay, now I will tell I about CD now. CD. Okay, start. Once again, I will do one thing now. I will change to CD now. All I will take change CD. CD. This I will remove. You should not do this way. You should write once again. Okay. Where is CD here? Okay, 1 minute. Okay. See, your CD is here. This is your CD. Okay. Do one thing. Okay, now what you do is, see, where the drop? Where from G, draw perpendicular HCD, say I'll complete now, HCD to CD, to CD. That is about which moment of inertia is required, CD. Okay, I will change all AB to CD now. I told CD can be anywhere. CD, okay. CD. You should write once again the sketch. Okay. Now, see here. Now, I will do one thing. I will write here. See, this is parallel to axis about which moment of inertia is to be calculated for this area considered. This is, that is parallel. I will 1 minute here. What I wrote there? Oh, no, something I wrote there. Okay, leave it. I will tell. I don't know what I wrote there. CD axis. This is CD. From here, this must be clear now. I told when the axis is horizontal, distance is vertical. When axis is vertical, distance is horizontal. Okay, now everything is changed here. You write once again, don't do this way, never do this way about CD. Okay, CD, moment of activity for that area considered shared area considered A, and for this area we want moment of inertia about CD using parallax theorem. Axis about which motion is required. Now CD. See what is CD? Right here now. See, CD is axis about which moment of inertia is to be. You should write after I correct everything. After I change everything, you should write. I'll go through once again now. If anything is omitted, axis about which moment of inertia is to be calculated. For that area considered equal to A, drop from G, from centroid, that is centroid of the area considered, drop perpendicular HCD to CD, that is axis about which moment of inertia is to be calculated. Okay. Then this is your HCD. Then by parallax theorem, ICD, moment of inertia of that area about CD equal to IG, moment of inertia of the area considered about its own centroidal axis parallel to CD, or you can do one thing, you can write here. See, that is, this IG is, you can write here. See, I will go this way. Is I about this axis for area considered. Furthermore, I can't give clarity. Area considered to make more clear. If you want ICD, you want first here, see, parallel to axis AB about which parallel. This is what? This is axis. If I don't write last time, write here. Axis parallel to axis about which, this is the axis, centroidal axis, parallel axis about which moment of inertia. Parallel. This is the axis parallel to axis about which moment of inertia is to be calculated. Axis about which moment of inertia is to be calculated. That is this one. This is I about this axis for area considered. So now IG equal to ICD equal to IG plus HCD square. 1 minute. I will pause and check anything is to be corrected, because I corrected that one. Okay. As far as I am observing, everything is corrected now. AB is removed, I introduce CD. Or now I will tell lastly, I will remove all this once again. See, now this everything I will remove. I will tell what to do. Nothing here. See, I will remove everything now. No area considered, nothing. See, everything I am removing. I am telling you systematically how to work out. Okay, see. Okay, now this way. Now, listen correctly what all how I explain. Go through it if you want 100 times. Go through it 100 times. Fully master it and record. You can, whenever you get doubt later, come back here and listen to what I am telling now. Note down the time when I tell the statement. When I start a problem later, I will not tell this much. See, suppose this is the area considered. See, green color I will put here. This is the area considered. Area considered equal to A, area equal to A, okay, for which moment of inertia is to be calculated calculated about some axis, anywhere, some axis, anything. Okay, do one thing. Imagine this is the axis right here. Imagine AB is the axis. Then imagine after AB is fully completed, imagine CD is the axis. You write here. Suppose this is the, once you write, first he will dictate how to find moment of inertia of this area considered about AB. Then he will tell how to find moment of inertia about CD. See, what I will tell is correctly identify which area you consider. Shading is not required later, this is the area. So in the mind should come, I want moment of inertia of this area. Okay, firm in the mind. Okay. Take a pencil, come to its centroid. Centroid, G, small g, not capital G. Some centroid. Put the pencil there, this way. And if you want to take rest, I will tell in the class, take rest. 15 minutes break, okay. 15 minutes be like this only. See, never bother about AB. When you come to centroid G of the area considered, you put here and then never bother about which axis you are doing, irrespective of whether you want I about AB, I about CD or I about any axis. Never bother. Okay, put here. Then after finish the break, after you are fully confident, now do one thing. First what you do is, through this point, you draw an axis, light line, which is parallel to required axis. Now I am explaining I about AB. See, right here. Now he is explaining I about AB, right mark. Now he is explaining I about AB. So through this centroid, you draw an axis, imagination or later light line pencil, draw an axis parallel to AB. Okay, AB over. Write what is moment of inertia about that axis, IG. Write what is moment of inertia about this axis. See, that is its own axis. Never bother about AB. But one thing, it should be parallel to AB. See, this should be parallel to AB. AB. Okay, that I is IG. Then plus bracket, whatever is this area, small a, not capital A, small a, into from centroid of where your finger is here. See, your finger is here. Now, don't remove the finger. From that point, you drop a perpendicular to this axis. I will call it as H or HAB, H to AB. Drop a perpendicular H to AB. You find this distance and then without forgetting square. This will give you I about AB. Okay. Now, next right here. Now he is explaining I about CD. See what to do. AB is, let the AB be there. Okay. Now what you do? Once again, take your pencil, come here, come to centroid. Put the finger here, put the point pencil pointed here. Take some rest, relax. Once you are ready, immediately draw and imagine, actually not very light line, draw an axis passing to the centroid and parallel to CD. See? Parallel to CD. Okay, now write what is I about this axis, that is IG. Write I about that what? Its own centroidal axis, whatever just you have considered parallel to required axis, IG. this IG is I about this axis plus area into, then most important term is this. From the centroid of that G, see, from centroid of the component G, you see, you require CD axis. So draw perpendicular to this axis. H perpendicular from G to CD. Find the distance HCD without forgetting square it. Square it over. You will get, that will give you I about CD. This much is sufficient. Okay. Now, to understand correctly, I will tell once again. Without the board, some area considered A. I want I about some axis here. Go to centroid. Go to that area, not centroid. Go to that area considered. Where is centroid of that one? Mark it. Whichever axis you want moment of inertia, you imagine a parallel axis, its own centroidal axis. That term is called IG. Write it. Plus area into this distance square. Okay. Or if you want about vertical axis, go to centroid of the component. Imagine an axis parallel to this axis but passing through its centroid this way. Plus area into this distance square. I think this much explanation is over sufficient for anybody. In future, I will not tell. In future, I will tell. If you got confusion, go back and study and come back. No, sir, we have not gone through it. Then go back. You should study everything. I told in as simple as possible manner. I am going to give application, but each and every class I can't tell, come to centroid, you imagine what, there is a limit for everything. So that's why I told this class I am uploading in 4 parts. Today's class is very powerful. Now what I will do is, I will give you some examples. Some examples. Now, a critical example, very thoroughly understand. What all I dictate you write. See, consider a lamina or some area here. See, sketch I will give part by part. Original sketch I won't give. See, maybe original sketch is given here. See, like this way, then this way, little this side, and then here on semicircle. Okay, this way. This is the original sketch given. All dimensions are given. See, dimensions are marked there. It is not a question, it is a demo. For this area, see, details are there. You have to find moment of inertia about 2 axes. One of them is AB, other is CD. CD I will show you a little later. First one thing, I about AB, how much? AB. Where is AB? They will tell here, from the bottom edge here, you come down by 275. Some random, given in the question. So this is your AB axis. See, this is your AB axis. About this axis, you require moment of inertia of this entire area. What you do? Entire area is a randomly arrangement. So, first you write the statement, then divide into parts. See, divide into parts. Okay, one rectangle I will take 1, one triangle I will take 2, one semicircle I will take 3, one more semicircle this way I will take 4. Quadrant I will not consider here. Okay. Then imagine these are the distances given all in millimeter. See, 125 plus 210 plus 300 is 210 plus 125 is 210, 310, 335 or 635, correct. And this is 250 given, diameter 250, so radius not required. this is 250, this full given is 450. So from 450, subtract 250, this gap is 200, and from here up to here, overall depth is 450 plus 150, 600. This full width is 635, full width is 600. This is the area given. Okay, now we have to find moment of inertia of this one about AB axis. AB axis is at 275 below the bottom edge. This is demo for parallax theorem. Okay, start. IAB by parallax theorem. Okay, 1 minute now. This I will remove now. Start. Correctly put the sketch. Remember, this is not a problem to solve. This is a demo class. Okay. AB is here. Okay. Start. IAB by parallax theorem. We want moment of inertia about AB for the entire part, entire area. So what you do, write what all I dictate, you write. Consider part by part. 1, 2, 3, 4 separately. Then, in general, see first right here, by parallel axis theorem, I about AB of any part or any area, either for 1 or for 2 or for 3 or 4, right? For any component or part is IG plus AH square. H is red color. AH square. AH square. IG is, you should write here, moment of inertia of the area considered. At a time we are considering only one area, or not all the cube. Area considered, once rectangle, then triangle, then semicircle, then again semicircle. Moment of inertia of the area considered about an axis passing through its own centroid but parallel to AB. Okay. A is the area of that part considered. H, perpendicular distance from centroid of the component to the required axis, that is AB, that is H. This is all right here. Now, here IG term I will not explain to you because this is part 2. Actually you know it all already over, but still summary I have not given. Till I give summary, you just believe me. See, IG, this will be fully clear to you in part 3 and part 4. Today, believe me. See, today, believe me. Today, believe me. Today, believe me. Actually, majority of people, they will tell, sir, we know it. Okay, if you know it, well and good. But right now, I have no time to explain that one. My purpose is to apply parallax theorem. Okay. IG, clear. Okay, now start. I about AB, first what you do is write some statement here. Statement. Consider each part separately and find I about AB. I about AB for 1, I about AB for 2, I about AB for 3, I about AB for 4. Find all the 4 by parallax theorem. Lastly, add all and get IAB for the entire lamina. That is IAB for 1, IAB for 2 plus IAB for 3 plus IAB for 4. Write the answer. This is lastly IAB for entire given lamina or area. Entire area is summation. Okay, now I will correctly explain. Remember, when I explain IG, I will write here, no doubt. I already told you, this will be, see, these 4 terms will be more and more explained in part 3 and 4. So do one thing, once I finish part 3 and 4, if you want, once again come back here and study this one. Okay, today believe me, actually you know it. Start. First come to 1. Okay, 1. See only 1, nothing else. See only 1. Mark, come to centroid. This is all I told you, see. Come to centroid. Axis passing to centroid and parallel to AB. Oh, it is this axis. I about this axis for this rectangle is 210 into 450 cube. See, full is 450 cube divided by 12. BD cube by 12. Parallel side into perpendicular side cube by 12. Anyway, I should not waste time now because today's class, it is not for IG. Ig comes in part 3 and part 4. So, okay, Ig over plus area 210 into 450 is the area into from centroid of the component to required axis, see this perpendicular square, see correct, clear, into, see this is G1, I will put G1 upper side, G1, I want to mark something, G3, little upper side, G2, this is G4, okay. From centroid here to red color, see correctly what I am doing now, then I remove it. From here, this distance square is 275 plus 150 plus 275 plus 150, you reach here, plus half of 450. That should be clear for you. See, 275 plus 150 plus half of 450 whole square will give I of 1 about AB axis. Or you can do one thing, instead of this way, you can write here, or 275 plus 600 minus half of 450. That also will do. See, 275 plus 600 will give you from here to here, 600 minus half of 450, answer will come same. You write it over. Come to figure number 2. See, okay, I'll remove this one now. First come to, I told centroid, come to centroid, G2. See, why G2 is here, this I will not explain today. See, that already told thousands of times earlier in the centroid chapter, or see, 1 by 3, 2 by 3 of 300, 1 by 3 or 2 by 3 of 450, thousands of times told. Next here, 2d by 3 pi, this is exactly midpoint. Here, this way is midpoint, this way is 2d by 3 pi, thousands of times told earlier. Let's start. First come to, see, its own centroid. See, come to its own centroid. Figure number 2. Imagine axis passing through centroid and parallel to AB. Write I about this axis. That is, the base is 300 into height is 450 cube divided by 36. This will be not question mark, means will be explained later for you. Today you put a question mark. Actually, if it is not clear, part 3 and part 4 will make it clear. Plus area, half into 300 into 450 area into from centroid of the component to the required axis. See, this distance square is 275 plus 150 plus 1 by 3 of, not this one, full is 450, don't see this one, 275 plus 150 plus, this is 450, 1 by 3 of 450 whole square. You write, or you can do one thing, 275 plus 600 minus 2 by 3 of 450 also will do. Okay. Come to figure number 3. Come to G3, its own centroidal axis parallel to which one? AB. Write I about this axis. In the next part 3 and 4, I will explain for this axis I is pi by 128 of diameter power 4. See, for this one, about this axis is pi by 128 of pi by 128 of diameter power 4. Y means it will come next class, okay, or already derived, plus area pi by 8 of 250 square is the area into from centroid of the component, see here, from centroid of that component to the axis, this square, this, see, from here to here, space problem here up to here, this distance is 275 plus 150, see here, 275 plus 150 plus 200 plus half of 250. Why? Diameter 250 means this is 250 by 2. 250 by 2 whole square. Or you can do one thing. 270, you write it. 275 plus 150 plus 600 minus half of 250. That also will do. Okay. Lastly come to figure number 4 here. First axis passing through its own centroid and parallel to AB somewhere here. For a semicircle, see, this axis I is pi by 128 diameter power 4, but about this axis moment of inertia is 0.00686 diameter power 4. It will come in part 3 and 4. 0.00, I told you this Ig today, you believe me, 0.00686 into 300 power 4 is I about this axis plus area into this distance square. See, this distance square is 275 plus 150 will give you this distance. 275 plus 150, from that one subtract this distance. This distance is 2d by 3 pi. You know it. Whole square over. Find how much is the answer. Find how much is the answer. Find the answer. Find the answer. Lastly, I about AB equal to IAB for 1 plus IAB for 2, IAB for 3, IAB for add all. You get moment of inertia of the entire given lamina about AB axis. Okay. This will complete about AB. Now I will write CD and I will do one thing to save the time. Okay, I first remove this one and make CD. Now make a note. You write. Just now we finished about AB. Now do one thing. Forget about AB now. See, AB is not there. They also want I about CD, some randomly given axis. Later remember, this AB can be centroidal axis for the entire lamina. That I will tell you later. So, CD. Where is CD? From the next extreme edge here. See, from this edge, 110 this side. It is given in the question. See, some distance to be given. I decided some random distance 110 from here. Okay. Now, ICD by parallax theorem. IG, this will be fully clear later. Today, believe me, plus A into H square. I about an axis passing to centroid of the component and parallel to CD axis. A, area of the component considered. H, perpendicular distance from centroid of that area considered, not entire area. Which area you consider? See, when you find 1 means area of 1. 2, the required axis CD, perpendicular. Axis vertical means horizontal distance. Okay, start. First, come here. Come to figure number 1. Come to its centroid. Its centroid is here. Axis passing through centroid and parallel to CD is here. See, I shifted G because it is disturbing the axis, this axis. Write I about this axis. You will be knowing tomorrow and day of tomorrow, next or you already know it. If you want I about this axis, it is, see, I about this axis, parallel side is 450 into 210 cube by 12. This all you will see, 450 into 210 cube divided by 12. I told you, this full IG term will be clear for you, much more clear for you in the coming up parts. Actually, you know it still because I have to give summary for you. Then once again example will be there. Okay. Plus area. See, area remains same as last time. I won't waste time area. 210 into 450 into from centroid of the component, see, to the required axis, this square. That square is 110. From here to here is 110 plus 125. Where you reached? You reached here, plus this distance is 210 by 2. 210 by 2 whole square will give I about CD for part 1. Okay. Come to part 2. Come to its centroid. See, its centroid is here. Axis passing through centroid and its own centroid parallel to CD. So here, see. Now, if for this axis, this will become the base 450 into 300 cube by 36. This will be clear for you later. 400 into 400, correct? Yes, not 400, 450. Okay. 450 into how much? 300. Don't calculate. 300 cube by 36 plus area of that component into this distance square is 110 plus 125. See, 110 plus 125 plus 210. From here to here over. See, we want this distance. See, this distance you want. See, this distance plus 1 by 3 of 300. Why 1 by 3? I can't explain now. Thousands of time told. Plus 1 by 3 of 300. That whole square will give for 2. Or you can do one thing. You can write one more thing. 110 plus 635 minus 2 by 3 of 300. That also will do. Okay, now figure number 3. Where is it? Here. First, we want I about CD. First, I about its own centroidal axis. Oh, for this axis, moment of inertia is not pi in terms of pi. It is 0.00686 into diameter power 4. Diameter power 4. This you have to wait for some time to get complete clear confusion. Last time, sir, you told pi by 128. Wait for a little more time. Go to part 3 and part 4. Full clarification I will give you. So this is today. I told today you believe me. Plus area into, see, into this distance square. From here to here, see. This distance square is 110 plus 125. 125. That will give you this distance minus this distance. That distance is minus 2 times diameter 250 divided by 3 pi. That number whole square will give I about CD of 3. Lastly, I about CD of fourth one. See, its own centroidal axis here. For this centroidal axis, moment of inertia is pi by 128 into diameter power 4. 300 power 4. See, for this one, about horizontal centroidal, it is pi by 128. About vertical centroid, 0.00686. But for this one, about vertical centroid is pi by 128. Whereas horizontal centroid, last time, 0.00686 will be clear in part 3 and 4. Plus area into, see, this distance square. This distance square is how much? 110 plus 125 plus 125, 110 plus 125 plus 210, then see 125, 110 plus 125 plus 210, then you reach here, see 125 plus 110 plus 125 plus 210 plus this way centroid is midpoint, diameter is 300 plus 300 by 2 whole square. Or you can do one thing, 110 plus 635 minus half of 300. That also will do. Find these 4 values. Finally, ICD for entire given area is ICD for 1, ICD for 2, ICD for 3 plus ICD for 4. Add all. You get I about CD of the entire given lamina. Okay. Now, demo is not over. One very critical concept is there which you require for steel structures, because their rolled sections they give property. So one more small concept is pending. I will make it ready and explain to you. Now, class, write everything I dictate. Somebody is telling there is a lamina here. See, someone is telling there is a lamina. It comes this way, comes this way, comes this way, comes this way, and comes this way. Okay. He wants moment of inertia about AB and CD. AB is same as last time, 275 here and 110 here. Okay, he will ask you to calculate. You tell him, okay, I will calculate, but what about division? This diameter, this width, this diameter, this height, etc. No. I am giving you overall dimension, 635 by 600. Okay. I want I about AB at 275, I about CD at 110 here. He will tell, I am not giving that one. Then how I can calculate? But I am giving you something else. I am giving you for the entire lamina, see, given in the question. See, very important. It is given in question. For the entire lamina, its area is, this all the complete lamina area is 222,478.49 mm square. Okay, done. Then this capital G is, see, he will tell you that capital G I am marking. See, that capital G, he is telling you that capital G I am marking, capital G is centroid for entire lamina. Entire lamina. Okay. And he will tell you, I calculated, because he knows what is the diameter, what is the width here, what is the diameter here, everything he knows, but he is not telling you. He is telling you, I calculated from here, left extreme edge, x bar, and he told all dimensions in millimeter, all in millimeter. He will tell you, see, you write here, centroid from here is at 256.16. Then he will tell, if you want, you can get from there, yes. Same way, centroid from here, y bar, he told 298.19. He told it comes somewhere here. Above this level, it comes somewhere here. Okay. Then he will tell, and I somehow calculated what is moment of inertia for the entire lamina about this centroidal axis, xx. It is 11384.84 10 to the power 6 millimeter power 4, and he will tell, I also calculated I about yy, that is equal to 10432.94 10 to the power 6, and he is telling you cannot calculate. Why? Because I am not giving you details of the, I am not giving you dimensions. I will give you only outer dimensions, area, ixx, iyy, and where is centroid. Now he will tell you, find I about AB and I about CD. When this will come, I will tell you. See, in steel structure, sometimes you may get a section. See, sometimes you get some sections here. One channel, see, some section may be there. One channel section here. One more channel here. And who knows, some plates may be there. This is a cross section of the column, etc. You may get in steel structures, or you may get some I section with the plates, etc. You may get it. Then for this channel section or channel section, he will, or this I section, they are called road section. For the channel section here, or for I section, what are the dimensions? What is its area? Where is its own centroid? No dividing into parts, no dividing, entire channel section or I section. Where is its centroid? What is I about this centroidal axis, xx and yy, here and here? They are all given in IS handbook for structural steel. Some people call steel tables. Okay. That you have to use. Or you write in the class, or today, what I told is useful when you go for calculation of moment of inertia in steel structure for built up sections consisting of multiple rolled steel cross sections. I section, angles. See, sometime angle will come, sometime channel. See, one term called plate girder comes. There, it will come this way. This way, this way. See, one angle here, welded or bolted or riveted. Okay, then for the angle, they will not give property. Okay, then how to find? So, briefly I will explain. That is, in case for a given lamina, you know where is centroid for the entire lamina and what is its area and what is the moment of inertia about its own centroidal axis. You can find about any other axis. Now, one thing you are right, these values are given by me randomly. See, this width, what I told last time, I am not telling you. Don't check it. Randomly, whatever comes to my mind, some numbers are given. See, given in the question I told you, you are not supposed to find IAB for this one and check with that value. It won't come same. See, anyway, first of all, overall dimension same, but diameter may change. So, answer will not tally. This is given like that. See, what to do? To find IAB and ICD using parallax theorem. First IAB, see here. What you do is consider the entire lamina as one unit. Only one unit. See, hatchet. This is your area considered equal to A just now. This full equal to A, or instead of A, you can call capital A. Why? There is no component, no dividing. Entire area is A. Now, this is centroid G for only what? For the not part by part. Entire lamina centroid G, or it is rather either G or this is G or capital G given here. And this is your axis parallel to AB and pass into centroid, or this is actually is XX. This axis. See, now if you want I about AB, this how much this is 275 given in the question. 275. See what to do. By IAB equal to IG. IG means or I about capital G. Okay. Either IG or it becomes I about capital G now. Or here, 1 minute. If you want I about AB, it is I about this axis. This axis. It is green and red both. That I about that axis is given in the question. See here, equal to, see here, I about this axis is XX. Oh, 11384, 11384.84 10 to the power 6 millimeter power 4. That is your IXX plus area of the entire lamina. Where is it? 222478. 222478.49. I gave the number randomly. Someone should think it is calculated. How I can calculate? Into most important what? Into, see, this distance square. That distance is 275. I use red color only. It is, that distance is, space is not there, 275 plus, see, from here to here is 275 plus this distance. That distance is 298.19 given in the question. 298.19 whole square. Calculate the answer. I will check the camera once, so that not out of camera. As I check the camera, mic fell down. Okay. Okay, done. No problem. Calculate, and today do not calculate, just understand. That's all. Understand, this is required for steel structure. So what you do is, instead of dividing into parts, entire given lamina, see basic definition is, this is for this one. If you want I about AB, first I about its own centroidal axis plus area into this distance square. Okay. Same way, if you want ICD, see now what to do. Now I don't have to explain much. ICD you want to calculate. Okay, draw CD here. This remove it. AB is cancelled now. This is cancelled. CD is here. See? CD is here. They told in the question, from CD to extreme edge here is how much? 110 in the question paper given or in the question given. This is 110 up to here. Start. By parallel axis theorem, ICD equal to once again IG. Which IG? Now it is, see, this IG. This axis. This is actually, you write here, axis passing to centroid and parallel to CD, but actually this is your YY axis. This is your YY axis. So IG is IYY plus area into H square. See the answer now? Correct? Or equal to, see, equal to, if you want I about CD axis, first I about this axis. That also is red color. Red means that red. If you want I about CD, it is IG. Entire lamina is 1 unit now. IG is I about this axis is I about that axis is, see, I about this axis is I about YY 10432.94 10 to the power 6. Someone should tell this. I wrote random number, but as if what, it is a real number. Plus area of the entire lamina 22478.49 into, from centroid here, that is G is nothing but this G to this axis, distance square. See, this distance is 110. Red, I write red color. It is 110 plus, see, from here, centroid to here, this distance square is 110 plus this distance is, that distance is, see here, they told it is 256.16 millimeter plus 256.16 millimeter whole square will give I about YY for the given lamina. Remember, this example is required only for steel structures, not for your engineering mechanics. Steel structures, you require it. Make a note. This, so that it is useful for those who are studying steel structures. It is required where properties for road sections are given, where suppose an I section given, you don't divide into parts. Entire I section take as 1 unit. These properties are given in the IS handbook or steel table. Okay, now part 2 is over. Next is part 3 and part 4. I will tell you part 3 and part 4 equally important. Part 3 I will give you standard expression for all shapes with a thorough explanation. And part 4 is application of parallel axis theorem for all the cases. Rectangle, triangle, all the cases. What you triangle in general, right angle triangle, then isosceles triangle, circle, semicircle, quadrant, one semicircle this way, one this way, everything. That is part 4. Part 3 will take a little time. Part 4 may be little lengthy, maybe 2 hours. Okay, then once part 4 is over, I will tell them, anybody in future, if they got difficulty, to first study part 1, part 2, part 3, part 4. If you have no intention of studying, if you are not serious, do not attend my class. I am not fit person for you to teach. I will tell. I should be strict in that matter. study each and everything. This portion need not be studied by people who are not interested in steel structures. Okay, we'll meet next time. Thank you.